Hi friends, welcome to Curie Electronics. This is the second part of 2018 SAC Ahmedabad question paper for Technician B Electronics Mechanic. So first I hope first part was useful for all of you. So today I will solve the second part, that is from question number 30 to 60, 30 questions. So we'll go, and you can get the previous 10 years question paper by WhatsApping me. You just WhatsApp me, I will send you the past 10 year ISRO different centers question paper. Okay, we will continue with the first question. Which of the following material has the highest dielectric strength? That means which will give more insulation for the voltage, electric field. That is, the answer is option C, mica. Mica has the highest dielectric strength. If you write in case of value, mica has got a dielectric strength of 5 to 9, and that of glass is the dielectric strength of glass equal to 4 to 5, and for air it is 1. And one more material you have to remember, that is ceramic. Ceramic has got a higher value, that is 81. So 81, ceramic is 81 dielectric strength. Question number 32. In the given circuit, if resistance 6 ohm is opened, the voltage drop across 4 ohm resistance will. So we have a circuit here, 3 resistors are there now. The question is what happens, now first of all he has given 4.8 volt, increase from 4.8 volt, decrease from, so we will find out when the circuit is not opened what is the value across the 4 ohm resistance. So here we have to find the V across 4 ohm. That's what the question is. Okay, now what has happened, this is like a voltage divider. We can draw it as a voltage divider. These two resistors, which two resistors? 6 ohm and sorry, which resistor? This is not 6 ohm, this is voltage. This 12 volt is connected here, 12 volt. What is this resistor value? This is 6 ohm from here, this circuit. This is like a reference point because the battery negative is connected here. So this is 6 ohm, this is 4 ohm. Okay, now what is the voltage across this 4 ohm resistor? What do? We will use the voltage divider rule. According to voltage divider rule, if I take this as V equals what? R2 divided by, that's a 4 ohm divided by sum of two resistors, 6 plus 4, 10, multiplied by the input voltage. What is V in 12 volt? Which equal to what? 4 12s are 48. 48 divided by 10, 4.8 volt. So 4.8 volt. Now what happens if this opens? What happens if this resistor opens? What happens if 6 ohm resistor is opened? Now 6 ohm resistor is opened, there is no current to this 4 ohm resistor. So the value will be 0. So how we can draw it? Once the 6 ohm resistor is open, the circuit will be like this. We have a 2 ohm resistor here. We have a 2 ohm resistor. This is a 12 volt. Then this is open. This is open end. Then we have a 4 ohm resistor here. It's a 4 ohm. So what will be the voltage across here? This will be 0 volt because there is no current flow through this resistor. So the answer is decreases from 4.8 volt to 0 volt. Question number 33. What is the temperature sensing limit of J-type thermocouple? What is the temperature sensing limit of J-type thermocouple? There are mainly two types of thermocouples, J-type and K-type. These are the main two types of thermocouples. And the J-type is made up of thermocouples are like this. The J-type is made up of this material, two metals, metal or alloy combinations. This is iron, and one more metal we should have. We should have a combination, alloy combination or metal combination. And here, this is, and here he will get this is the hot junction. Hot junction. Here, this metal is, what is this metal? This metal is constantan. How do you write constantan? So this J-type thermocouple is a combination of iron and constantan. Now, this temperature range is from minus 210 degrees Celsius to 1200 degrees Celsius. This can sense. And if you take the K-type also similarly a combination of two. K-type is also a combination of two metals or alloys. Two type. It's an alloy. Oh, sorry, I have to. It's an alloy. Okay, I'll take a different color pen. It's an alloy. So these are two different materials. Okay, two different alloys are used to make the thermocouple. And here this is the hot junction. This is a hot junction. And one is called chromal. This is chromal. Okay, this is aluminum. There will be a polarity also, negative and positive. This is negative. This is aluminum. This alloy is aluminum, and this alloy is chromal. These are for your information. Then only any use of watching this video. Otherwise, simply if I take the answer and go, no use to you. Chromal. This is made of chromal. So K-type is a combination of chromal and aluminum. And this has got a temperature. This has got a temperature range of minus 200 to 1250 degrees Celsius. So if you see, look at it, both are somewhat similar. So what is the question? What is the temperature sensing limit of J-type thermocouple? If you take J-type thermocouple, it can sense this temperature range easily, minus 210 to 760 degrees Celsius. So the answer is option D. Both can sense the temperature, the similar range, but they are in the similar range. But answer, they are asked for J-type, so answer is option D. Question number 34. A class B push-pull amplifier, the efficiency can reach up to, what is the maximum efficiency of ideal efficiency? Efficiency class B. Ideal equal to 78.5%. Class B. So the answer is option B. If it is class A, ideal, then it equal to 50%. It can reach up to 50%. And if it is class C, it can reach up to 90%. So we'll go to the next question. Question number 35. For a purely resistive AC circuit, power factor is unity. That is what ideally we want. Ideally we want the power factor to be, the previous question I ticked yes. For a purely resistive AC circuit, power factor is, the answer is option D, unity. For a DC circuit also, DC circuit, power factor equal to unity. Unity means 1, value is 1. Now what is power factor? That is represented by cos phi. Cos phi equal to active power divided by reactive power plus active power. That is what power factor, which can be in terms of resistance and impedance R by Z. That is the power factor equation. This is PF, power factor equals. So we'll go to the next question. The rate of change in electric charge is called. Rate of change in electric charge is called. What is rate of change of charge means dq by dt, that is I. The rate of change of charge is current. Answer C. 1 Tesla equal to what? 1 Tesla equal to what? 1 Tesla equal to 1 Weber per meter square, which equal to what? 10,000 Gauss. 10,000 Gauss. Gauss. 10,000 Gauss. This is 10,000 Gauss. So the answer is option D. What is this unit of what? Flux density. Magnetic flux density. Unit of magnetic flux density. Question number. What is the question number? Question number 38. 7,200 millivolt is same as the voltage is given 7,200 millivolt. Now 1000 millivolt equal to what? Equal to 1 volt. So similar way, if I divide this 7,200 divided by 1000, then I'll get 7.2 volt. This answer is option D, 7.2 volt. Option D is the answer, 7.2 volt. Identify the waveform. What is the waveform shown? This is a triangular wave. It's a triangular wave. Answer is option C. Now how does the sawtooth wave looks? Sawtooth wave looks like this. It falls again, it will not. This is the sawtooth. This is not a triangular. See, it comes like this. I'll show you the better way. See, it comes, it drops, falls, again it rises, falls, again. So it repeats. This is the sawtooth waveform. So question number 40. In a 5-branch parallel circuit, there are 12 milliamps of current in each branch. If one of the branches opens, the current in each of the other 4 branches is. Now we have 5 branches, parallel branches. Let us take impedance. 5 branches means 5 impedances are there. 5 impedances are there. This is the second one. So like this, we have 5 branches. We have 5 branches. Fourth one, this is 5 branches are there. Okay, now we have 5 branches connected in parallel. Now each branch is taking 12 milliamps of current. 12 milliamps of current. So all branches 12 milliamps of current is flowing. 12 milliamps. Here also 12 milliamps. Here also 12 milliamps. Here also 12 milliamps. 12 milliamps of current is flowing. Now the question is, if one of the branch opens, the current in each of the other four branches is. See, now one branch opens, what happens? One branch opens, this goes off. Read the question once more now. In a 5-branch parallel circuit, there are 12 milliamps of current in each branch. If one of the branch opens, the current in each of the other 4 branches is, that is 12 milliamps. In remaining 4 branches, 12 milliamps will be flowing. Okay. So question number 41. Which of the logic is the slowest? Out of this, DTL logic is the slowest. After DTL, then comes CMOS. DTL is faster than CMOS. Then comes the RTL. Then comes the TTL. Okay, so DTL is the slowest. Question number 42. When PN junction diode is forward biased, what happens? When a diode is forward biased, the depletion region width decreases and diode offers low resistance. So the answer is option A. Question number 43. In a forward biased resistor, as a direct question, in a forward biased transistor, what is the current relation? I in a transistor, total current equal to base current, emitter current equal to base current plus collector current. That is, if you see a resistor like this, this will be the transistor. Sorry, this is IE. This will be IE. This will be IE. Then this will be IC. IC will be coming in. Base also coming in. This current is going out. This will be IB. So emitter current is sum of IB plus IC. IE equal to IC plus IB. Question number 44. If separation between two plates of a capacitor is increased, its capacitance will. What is the equation for capacitance? A epsilon divided by D. So D is in the denominator. So if D increases, D is the distance between the two plates. If D increases, what happens to the capacitance? Capacitance decreases. So the answer is option C, decrease. Because it is in the denominator and we are increasing the denominator value. Question number 45. In a series RLC circuit at low frequency, the circuit is. In a series LC circuit, what is the resonant frequency? Resonance frequency 1 by 2 pi root LC. Root LC is the resonance frequency. And if you see the graph, these are the low frequency region. Low frequency. This is the high frequency. The low frequency region, capacity reactance is leading. So it will be the circuit is more capacitive. The answer is option C. But if you see here, the higher frequency, it's a higher frequency. Inductive reactance is leading. And you see, there is one more relation you can find from this value. If the R of the circuit is small, the bandwidth is going to be very narrow. If R is higher, then bandwidth will be more in a series RC circuit. 46. Question number 46. Question number 40 is maximum efficiency of half wave rectifier is. Maximum efficiency of half wave rectifier is. I wanted to show you one table. I think I have not put it here. Let me see. It is there? No, sorry. It's not the one. Actually, I have put one table. Okay. Now here, maximum efficiency of half wave rectifier is. What is the maximum efficiency of half wave rectifier? Answer is option C, 40.6. For a full wave rectifier, what is the efficiency? Full wave efficiency equal to 81.2. That is the efficiency of the full wave rectifier. Question number 47. A transformer has has a turns ratio of 2 is to 1. What is the peak secondary voltage if 115 volt VRMS is applied to the primary winding? Now turns ratio is given by 2 is to 1. What is turns ratio? That is secondary is to E primary. That is secondary voltage is to primary voltage. This is the turns ratio, and there is a relation between turns ratio of E between the voltage and the number of turns, that is ES divided by EP equals NS upon NP. Now ES, what is the turns ratio here? 2. 2 is the secondary. 2, that is 2 by 1 equal, and NS we don't know. NS is what we have to calculate. Primary winding has given 115 volt RMS voltage. This is the RMS voltage. The secondary we get 230 volt RMS. But the question he has asked the peak secondary voltage. So we have to convert this RMS to peak. So what is V peak? V peak equal to root 2 times 230 volt. So what is the value? Above higher greater than 230. Now 230, the answer should be option D. How? You need not to calculate. Why? Because this, when you multiply, you should, that is the greater number than, that's a bigger number than 230 or greater than 230. Okay, now question number 48. Color code for 85 kilo ohm 5% tolerance resistor is, what is 85 kilo ohm? What is the color code? 8 is gray. 5, what is 5? Green. Kilo ohm orange will give you 10 to the power 3 orange. 5% tolerance, that is gold. So this will be 8 5 multiplier 10 to the power 3 4 band resistor plus or minus 5%. So the answer is gray, green, orange, gold, option C. Question number 49. The question is the ripple factor of a bridge rectifier is. Bridge rectifier means full wave. Bridge rectifier ripple factor. This is the efficiency. 81.2% is the efficiency of the bridge rectifier. But the ripple factor of full wave bridge rectifier is 0.48 actually. So 0.48 is the answer, ripple factor, but it is not there in the question. And this is for half wave rectifier. Half wave rectifier, it is 1.21. So here you can go through this table and you can learn it. Comparison between ripple factor. See here, it is given for a bridge type ripple factor equal to 0.48. For a full wave also 48. And efficiency is there. Peak inverse voltage. Only for the center tap 2 Vm is required. 2 Vm is a peak inverse voltage required for the diodes. If you are using bridge rectifier, then peak inverse voltage will be Vm only. So we'll go to the next question. Current 3.2 multiplied by 10 to the power minus 5 amps. It can be written how? It can be written neatly. Then what is given? 3.2 into 10 to the power minus 5 is given, which can be written how? We can write 32 into 10 to the power minus 6, which is equal to 32 micro amps. We can write it as 32 micro amps. So the answer is option A, 32 micro amps. Next question. Question number: a permanent magnet will not attract it. A magnet won't attract copper. But what happens? You take one round magnet and put it in a copper coil. What happens? It falls slowly through the copper tube. That is Lenz law. That is due to Lenz law. So we know steel will get attracted to magnet, iron also will get attracted, nickel also will get attracted. So copper doesn't attract the magnet. Question number 52. Main purpose of laminating a transformer core is to decrease its what eddy current loss. Hysteresis loss. Hysteresis loss. What is the reason for hysteresis loss? That is due to the magnetic field direction has to be changed each time. That causes hysteresis loss. So question number 53. The resistivity of a conductor depends on what is we know one equation R equal to rho L by A. Here rho is the resistivity. Rho equal to resistivity. So we know that is resistivity. Now what is this in our textbook? There's one table for the resistivity of different materials, like copper resistivity of copper equal to 1.7 into 10 to the power minus 6 ohm centimeter, and for steel no, steel only. No, not for steel. Silver. Sorry, silver. For silver, it is 1.6 into 10 to the power minus 6 ohms per centimeter. That's a big table. There are many materials. So, the resistive conductor depends on type of material. Answer is option C. Question number 54. Calculate the effective capacitance for the following circuit. Now, when two capacitors, so C1, C2 equal to 20 microfarad is given, C3 equal to 15 microfarad. Capacitors in series. Capacitors in series. What happens when capacitors are connected in series? What is the equation? Two capacitors are there means like a resistors connected in parallel. C1, C2 divided by C1 plus C2. So what is C1? 20, both are 20 microfarad. The 20 microfarad means we should get 10 microfarad. That is from here where it comes. If two resistors are connected in parallel, here we will get CT equal to capacitance divided by the number of capacitors. Two capacitors same, they are connected in series 20. So 20 divided by 10 equal to 20 divided by 2. Sorry, 2 equals to 10 microfarad we will get. Now this 2 microfarad, sorry, 10 microfarad. I'm drawing resistance. Sorry. So this, what is this? What we got? 10 microfarad. This 10 microfarad is in parallel with the C3 value 15 microfarad. 15 microfarad. Okay. So what will be the equivalent capacitance if we measure from here? It's like a series combination of resistors. So we'll just add the capacitors. So C total equal to 10 plus 15, that is 25 microfarad. 25 microfarad. We'll get 25 microfarad. Answer is option C, 25 microfarad. In a series circuit, in the current is, you have many resistors like this. Just take one inductor will be there, capacitor will be there. So what will be the current through this circuit? One current I will flow, and through the entire circuit it will be same or constant. We can say it as constant. Question number 56. When you increase the resistance in a circuit, the flow of electrons will, when the resistance will oppose the flow of electrons. So the flow of electrons will be decreased. Question number 57. If a small value of capacitance is connected in parallel with a large value, the combined capacitance will be. Now already we have seen when capacitors are connected in parallel, they will get added C1, C2. CT will be C1 plus C2. So the effective capacitance will be higher than. If a small value of capacitance is connected in parallel with a large value, the combined capacitance will be higher. That means if the small value will be get added to the whatever higher value, whatever is there, it will get added. It's just like a resistors connected in series. Question number 58. The main energy losses in an optical fiber consist of. There's a bend loss is there, light scattering loss is there, material loss is there. So the answer is all the above. 59. The diode with variable capacitance, that is asking what is this? We all know it's a varactor diode. What is the symbol for tunnel diode? This is a tunnel diode. Track, how the track will be? Track is a both way it can conduct AC. This will be the MT2, MT1, MT1. That should be a gate also. I think this is the gate. Okay. Now today's last question. So we are completing the second part. Third part, I will try to put it this week itself. Let me see. If the time permits, I will update it this week itself. Since input resistance of an ideal op-amp is infinite, for an ideal op-amp, output resistance is 0. Answer is option A. So all of you, please share the videos with your friends. And see, if any of you want the question paper, around 10 years question paper for Technician B Electronics, you could WhatsApp me. Just WhatsApp me, I need the question papers. I will send you the question papers. I may ask you to please subscribe the channel, that's all, nothing else. Okay, guys, thanks for watching. See you soon. Thank you.